Hey guys, this is Ms. Diaz, and I'm going to go ahead and show you some notes for partial fractions. So before we begin, I actually want to remind you of what we did last semester. It's been a little while, so I need to refresh your memory. But last semester, we were given something like 4x minus 3 divided by x plus 5 over x minus 1. And I asked you guys to write out the partial decomposition. So to write it out, we had to write out a over x plus 5 plus b over x minus 1. And that's it. You have to break it into two fractions using the denominator pieces. If you have a linear piece, on the top you're going to have just a constant, which is represented by a. So I'm going to show you another example where we might not have a linear piece. Let's do one more example like this. What if I give you 4x minus 7 over x plus 1 and x plus 3? Well, in that case, we would just write a over x plus 1 plus b over x plus 3. And so if I'm not giving a linear component, for example, 4x plus 5 over x squared plus 1, notice x squared plus 1 is a quadratic. And we can try to factor the quadratic, but unfortunately this is not factorable. If you try to factor this, you're going to end up with imaginary numbers, but we are not going to work with imaginaries for this section. So we're going to write it out as a x plus b over x squared plus 1. So anytime you have a quadratic that's not factorable, you're going to write a linear component. So remember, my linear functions are my mx plus b, but we usually just start with the first letter of the alphabet. That's why you guys will see the a first there, okay? Let me give you a few more examples. So what if I have 4x plus 9 over x squared? Well, if you notice, we have x squared now. We actually are going to write this as a over x plus b over x squared, okay? And basically what we're looking at is x squared is factorable. It's x times x. So that's why we're going to go ahead and leave these as constants on the top. Even though this is a quadratic, we're leaving it as a constant because we're building up this piece up to the x squared component. So for example, if I gave you 4x plus 9 over x cubed, that would actually be a over x plus b over x squared plus c over x cubed. And that's how we would write out this partial decomposition fraction. All right, and so these are just a few examples. I wanted to show you what we did last semester. I'm hoping that it brings back some memories, and this is all we asked last semester from you, to write it all out. But today we're going to solve for the coefficients. Today we're actually solving. So I'm going to ask you guys to take out your notes, which look like this. Okay, and we're going to do just a few examples. I'm going to tell you guys right now, we're going to skip page 2. So we're just doing page 1 and then page 3, which looks like one example on the last page. We're not going to worry too much about that page 2. So don't stress about page 2. Okay, so let's get started. So I'm going to show you something called a cover-up method. To use the cover-up method, this only works for non-repeated linear factors. Okay, so this will only work if we have linear factors, just like I showed you at the beginning, but they are going to be non-repeated linear. So let's just dive into an example. It says find the partial fraction decomposition of 5x minus 1 over x squared minus 2x minus 15. To show where we are heading, we will clear the fractions and solve the system first without the shortcut. So I'm going to show you this strategy, and then we're going to factor the denominator. That's actually first step, and then write out the partial fraction decomposition. So we have 5x minus 1 over x squared minus 2x minus 15. What I'm going to do first is I need to factor this quadratic. It is factorable. So 5x minus 1 over x minus 5 and x plus 3. I believe those are my factors. So to write it out as a partial fraction decomposition like we did at the beginning of the video, it would be a over x minus 5 plus b over x plus 3. And normally we'd be done, at least in the first semester. We would just write it out. Today, we're going to solve for a and b. So I'm going to show you how to solve for a and b. And what did I say? Yeah, let's solve for a and b. So to do so, what you guys are going to notice is this is kind of what I'm working with. This is a rational function, so this relates to our rational functions. We can see the vertical asymptotes, we can see the x-intercept, all right? We can see horizontal asymptote, blah, it's to see. So this is a rational function. To do this problem, we need to find a common denominator. Do you guys see how x minus 5 and x plus 3 are the denominators here? Well, we're going to have to get a common denominator. What that means is I'm going to multiply a times the x plus 3 and the b times the x minus 5. So if I were to do so, I'm multiplying x plus 3 x minus 5 here, x minus 5 there. So x minus 5s, and over here I'd be multiplying by the x plus 3s, the x plus 3s. And now you see how we have the common denominator. Now, once you get a common denominator, all I'm working with is the numerator. So I'm going to write out the numerator. You're going to get 5x minus 1, that's the numerator here, equals a times x plus 3 plus b times x minus 5. All right, that's what happens when you write in pen. Can't really erase, that's okay. So now we have a function. We have an equation. We're going to go ahead and solve for a and b. And to solve for a, I'm going to start off with a. Let's plug in x equals, let's plug in x equals 5 first. The reason I want to plug in 5 is because what happens when I do 5 minus 5? 5 minus 5 is going to give us that 0, which cancels out b. So let's plug in 5 for all the x's. 5 times 5, and then minus 1 equals a times 5 plus 3 plus b times 5 minus 5. Well, that's going to turn into 0. 5 plus 3 is 8, so 8a equals 25 minus 1 is 24. Divided by 8, a equals 3. And we found a just like that. We're going to do the same thing to find b, but this time I'm going to substitute -3. Do you see if I substitute -3, I'm going to get a to cancel. So let's try this one. 5 times -3 minus 1 equals a times -3 plus 3 plus b times -3 minus 5. And that's going to be -15 minus 1, -16 equals 0, and then minus 8b. Divide both sides by -8. Looks like b equals +2. +2. And we have our a and b. So the last step is to rewrite the fraction. So a was 3 over x minus 5 plus b was 2. Can you see? 2 over x plus 3. We're going to box that answer, and that's our partial fraction. All right. Now you might be thinking, okay, well, what does this even mean? Why did we do that? Well, in pre-cal, we're actually working backwards. See, in Algebra 2, you were given these components, and you were asked to add them together to find the final answer, the fraction, the rational function. So let's test it. Let's make sure this works. I'm going to actually pull this on the scratch paper that I was working on earlier. Okay, so if I have 3 over x minus 5 plus 2 over x plus 3, and I want to add them together, well, we know if we're adding fractions, you have to have a common denominator. So we're going to multiply this by x minus 5, and we're going to multiply this one by x plus 3, and x plus 3. And then we're going to go ahead and distribute the top, so 2x minus 10, and then over here is 3x plus 9, 3x plus 9, plus 2x plus 10, all over the common denominator, which is x plus 3 times x minus 5. And we're going to add those together, combine like terms on the top. It looks like 5x minus 1 over x squared minus 2x minus 15, which was the original here. 5x minus 1 over x squared minus 2x minus 15, excuse me, which means we did it correctly. Yeah. All right, stick around because I'm gonna go ahead and do a few more examples for you on the next video. And try it out. If you feel like comfortable with this, go ahead and try it out on your own. All right, sweet.